LangGraph implements a streaming system that enables real-time data emission from graph nodes, allowing applications to surface updates progressively and enhance responsiveness. This mechanism supports multiple streaming modes, including custom data streams that can be emitted directly from node functions. The code demonstrates how to configure a graph to stream custom data by defining a state schema, creating a node that emits custom key-value pairs using the stream writer, and compiling the graph with a custom stream mode. When executed, the graph will yield the custom data chunks as they are emitted from the node, showcasing the flexibility of LangGraph's streaming capabilities.
From typing import type dict. From LangGraph, config import get stream writer. From LangGraph, graph import state graph start. Class state type dict. Query SDR. Answer SDR. Def node state. Hash get the stream writer to send custom data. Writer equals get stream writer. Hash emit a custom key value pair, e.g. progress update. Writer custom key, generating custom data inside node. Return answer, some data. Graph equals state graph state. Add node. Add edge start, node. Compile. Inputs equals query. Example. Hash set stream mode equals custom to receive the custom data in the stream. For chunk in graph, stream inputs stream mode equals custom. Print chunk.
This code demonstrates LangGraph's custom streaming capability, allowing nodes to emit arbitrary data during execution. The pattern uses getStreamWriter to access a stream writer within a node function, enabling real-time emission of custom key-value pairs like progress updates or intermediate results. This approach is particularly valuable when integrating external services or raw LLM clients that don't follow LangChain's chat model interface, as it provides a flexible streaming mechanism independent of specific API implementations. The implementation shows a simple graph with a single node that writes custom data to the stream using writer custom key, generating custom data inside node. When the graph is executed with stream mode equals custom, these custom emissions are yielded in the stream alongside the node's return value. This design allows for granular control over what data gets streamed, making it suitable for scenarios where you need to surface internal processing states or custom metrics without exposing them in the final state. The trade-off here is between flexibility and structure. While custom streaming offers maximum control, it requires explicit handling of the stream writer and careful coordination between what's streamed and what's returned. The pattern is especially useful for debugging, progress tracking, or when working with non-standard LLM APIs, though it does add complexity compared to simpler streaming modes like updates or values that automatically handle state changes. Let's break it down.
From typing import type dict.
Imports typed dict from the typing module, which enables creating dictionary types with specific key-value type annotations for type checking and code clarity.
From LangGraph, config import getStreamWriter.
Imports the getStreamWriter function from the LangGraph configuration module, which provides functionality for creating stream writers used in custom streaming modes.
From LangGraph, graph import state graph start.
Imports state graph and start from the LangGraph graph module. State graph is a class for constructing stateful graphs, while start is a constant representing the entry point in a graph workflow.
Class state type dict
defines a state class that inherits from typed dict, establishing a type-hinted dictionary structure for representing state data in the application. This enables type checking and IDE support for dictionary keys and their expected value types, improving code reliability and developer experience.
Def node state, state.
Defines a function named node that accepts a single parameter, state, with type annotation, state. This establishes a callable that processes or transforms the provided state object, likely as part of a graph node operation in LangGraph. The function signature indicates it's designed to work within a stateful computation graph where nodes receive and potentially modify state data.
Hash get the stream writer to send custom data. Writer equals get stream writer.
Calls get stream writer and assigns the returned stream writer object to the variable writer. This retrieves a writer instance that can be used to send custom data through LangGraph's streaming system.
Hash emit a custom key value pair, e.g., progress update. Writer custom key, generating custom data inside node.
Calls the writer function with a dictionary containing a custom key value pair, emitting, generating custom data inside node under the key custom key. This sends a custom progress update or arbitrary data through LangGraph's streaming system in custom mode.
Return answer, some data.
Returns a dictionary with a single key answer mapped to the string value, some data. This represents the output format expected by the node, where the result is structured as a key value pair that can be processed downstream in the graph.
State graph state.
Creates a new state graph instance initialized with the state class. This establishes a graph structure where state defines the data model for nodes and edges in the workflow. The constructor call sets up the foundational graph object, but doesn't yet define any nodes, edges, or execution logic.
Add node.
Adds a node to the graph. The node parameter specifies which node to add to the graph structure.
Add edge start, node.
Adds a directed edge from the start node to a node named node in the graph structure. This establishes a connection where execution can flow from the starting point to the specified node.
Compile.
Compiles the LangGraph workflow into an executable graph structure. This method call finalizes the graph definition and prepares it for execution, enabling the streaming capabilities and node orchestration defined in the graph.
Inputs equals query. Example.
Creates a dictionary named inputs with a single key, query, mapped to the string value, example. This establishes a basic input structure that could be used to pass data into a LangGraph workflow or node, though the specific usage isn't visible in this segment. The dictionary follows standard Python syntax for key value pairs.
For chunk in graph, stream inputs, stream mode equals custom.
Iterates over chunks of data streamed from the graph using custom streaming mode. The graph stream method is called with inputs as the input data and stream mode equals custom to enable streaming of custom data from graph nodes. Each iteration processes a chunk of the streamed output.
Print chunk.
Prints the value of the variable chunk to the standard output. LangGraph's custom streaming mode provides a flexible way to emit real-time data directly from graph nodes, enabling applications to surface updates progressively. The pattern involves defining a state schema, creating a node that uses getStreamWriter to emit custom key value pairs, and compiling the graph with stream mode equals custom. This approach is particularly useful for integrating external services or raw LLM clients that don't follow standard interfaces, as it allows arbitrary data emission independent of specific API implementations. The implementation demonstrates a simple graph with a single node that writes custom data to the stream using writer custom key, generating custom data inside node. When executed with stream mode equals custom, These custom emissions are yielded alongside the node's return value, providing granular control over streamed data. This design is valuable for debugging, progress tracking, or surfacing internal processing states without exposing them in the final state. The trade-off here is between flexibility and structure. While custom streaming offers maximum control, it requires explicit handling of the stream writer and careful coordination between stream data and node returns. This pattern adds complexity compared to simpler streaming modes like updates or values, but it's essential for scenarios requiring custom metrics or non-standard LLM API integration.
The node whispers secrets to the stream writer, who dutifully scribbles them into the void.